Okay, so I'm going to move on to adding relocations to the elf file. But before I do that, there's a couple of places to just clean up with the symbol stuff that I did last time. And I think there are a few places in here that would actually cause some bugs or wouldn't work very well if I did sort of like consecutive calls to the right function. So I think maybe I'll just clean that up first. So the first thing is that in this write to function, I basically find these sections that the writer needs to sort of add strings and for the section headers and the symbols. But these are sort of used, because they're used by the write function to do stuff like adding strings, it means that if I call this write to function again and again, that data is just going to keep on building up and up in the section. That isn't so much of a problem with the add strings, but it does mean that, for example, this symbol table will just have the same symbols appended to it again and again. So I need some way of clearing these out. So let's say that we have, for example, the section header string table here. I'd like to call, for example, clear on this, and that will just wipe out the data and clear the strings map. So we can do that there, and we can also call clear on the symbol table and the symbol string table. So this will be a new function on section. We just run clear. So this will just do like a clear on s.strings, and we'll set s.data equal to s.data and truncate it to a 0 length slice. That means that this is going to be broken now, so we'll do something like saying if it's nil the first time we come through, we'll just call this in make. So we'll just make the map, and then if the length of s.data is 0 at this point, then we'll basically just set manually the empty string to be 0 as the offset. And then instead of just resetting this byte slice here, we'll just reuse the existing storage if it exists by just calling append instead. So I think that's everything in add string, and that lets me clear out any data for consecutive runs to the write to. I also do this thing where in the file, if the first section that if there are no sections, for example, and the one that you're adding has a type of null, then I assume that you're basically adding the null section yourself. And so if it's not that, then I add one for you. Instead of passing in an actual section for this, I think what I'm going to do for this is just say that if you pass in nil, then that counts as you adding the null section yourself. So if the sections is 0, if the length of sections is 0, and you're not passing in nil, then I add a nil one for you. Then we need to just say that if the section is nil, we'll just set it to some empty section. And then I can do the same thing down here for symbols as well. So if symbol is not nil, then it means we're not adding a null symbol, so we just add one ourselves. And actually this can just stay empty because that's going to be the undefined symbol anyway. Then this sorts func isn't actually very good. It works for the test because I only had 2 symbols in there, one local, one global. But really I think I actually want to do this sorting on write. So when we clear everything out, before we do the symbols loop, we'll just do a sort on them. And actually if I use a sort stable func, then at least things that are equal to each other will stay in the order that they were inserted in the first place. So for this, basically, I just want to check if we've got A is local. So this is if this is stb local, and we'll check if B is local as well. And then we'll do a switch in here to say that if A is local and B is not local, then we'll return -1 to put A further at the beginning of the slice. In the opposite case, where A is not local and B is local, we'll move it forwards, and then in the default case, we'll just say that they're equal to each other. So that sorts out the symbols here. On consecutive runs, this will actually break, especially if I'm clearing out data. So basically, if I'm reusing the symbol table and this is already set, but symbols have changed, then this is not going to run at all. So I thought here perhaps what I'll do is I'll just initialize this with the length of symtab dot, what should I initialize this with? Symbols, yeah, because this is the highest symbol. We can use that as a sentinel for whether to do this or not. So basically, the first time that we find something that's not local and this is equal to the length here, then we'll set it. So that means that for consecutive runs, this should reset the symtab info each time, which is supposed to be the index of the first weak or global symbol. Let's carry on down and have more of a look. Oh, also actually with symbols, the first symbol is always supposed to be the null symbol, so I actually only want to sort from index 1 onwards, and we'll leave the 0th index where it is. I think that might be about it. Currently I'm also actually, now that I look at this, I'm padding out the section data for each section to force the section headers to start on an 8-byte offset. That was just the easiest way that I could think of doing it last time while I was writing this loop, but I may as well actually take this out of here and just store let's call it section header padding. So section header padding, actually we'll put this here, this will be the calculation. So section header padding is basically the aligned section header offset to 8-byte alignment minus the section header offset. Then we can just plus equals the section header padding to the actual offset that we've got. And then what we can do is come down here and say something like, let's just copy this, we'll put it after the sections but before the section headers. So we'll say that if we actually have some padding, then we'll try and write it. So this is writing section header padding. So here we'll basically just make a byte slice of section header padding, and that can be written before we do the section headers to make sure that they start on an 8-byte alignment. And then that way I don't have to pad all of the section data for no reason. So I think the rest of this should be okay. See, add symbol, add section, add string. Oh, I actually found out recently that this, I don't have to convert to a byte slice to spread bytes into this slice here. Okay, so let's just try run of this. Okay, so there's no function string. Oh, this is strings. Okay, cannot use section. This will be where I copied it into the symbol one. And then symtab symbols. This should be file symbols. And I've done the same thing again here. Okay, let's do read elf on this and just make sure. So the symbol table still has the index of the first non-local symbol as being 1, which is correct down here. The start of section headers here is 176, which looks like it's correct. And then if I run LD on this and run the program and echo the output, we get 100, which if I look at main, start is here, 100 is being pushed into DI here, and then we're pushing the index 60 into AX here, and then doing syscall, which calls the exits function. So I think now would be a good time to add relocations. So I've got this relocation chapter here in the GABI ELF PDF. So relocation is the process of connecting symbolic references with symbolic definitions. For example, when a program calls a function, the associated call instruction must transfer control to the proper destination address at execution. Relocatable files must have relocation entries, which describe how to modify the section contents, thus allowing executable and shared objects files to hold the right information for a process's program image. So if we're trying to do something like call a function in a shared library, like libc or something, we don't know what the displacement for that is going to be, or the address or anything like that. So we need to create a relocation to say that we have this symbol that we're trying to call. It's a function, you know, it's a 32-bit, this is the addend, and then the linker can either patch that in, the static linker, if it can resolve everything, and if not, then the static linker can create some dynamic link metadata in the final executable for the dynamic linker to patch in for us instead. Or, you know, the static linker might set up like procedure linkage tables and things like that. So the offset of a relocation is the offset, the location at which to apply the relocation action. So this will be the fixup offset that I've got. So for a relocatable file, the value is the byte offset from the beginning of the section to the storage unit affected by the relocation. So if we have a symbol in the text section, let's say that we start with a call. The call will be like a single byte for an opcode, and then it will be offset 1 will be like a 32-bit displacement for the actual like address. So the offset here would be 1. Info then gives both the symbol table index with respect to the relocation, with respect to which the relocation must be made, and the type of relocation to apply. So the symbol is the index in the symbol table. So if we had the name of a symbol that we're trying to call, then we basically, you know, if we were trying to call, for example, this start one, then that would be index 1. Then we've got a type of relocation, which is basically these R underscore constants here. So basically, in the beginning, I'll just be using PC32 and PLT32. But maybe a bit later, we'll also put in, for example, this global offset table, PC-rel. There's also these X versions for like relaxable versions. The rest of it, I think, will mostly be ignored. Some of these are just in here for documentation and are sort of not really for use if you want to keep to the ABI. But we'll start with the PC32 and PLT32. So PLT32 will be for like the fix-up branches, which will be like calls and jumps. And then PC32 will be for like, you know, relocation to like the offset of some data or something like that. So like if I were to put a string into the read-only data section to pass to printf or something. So maybe what I'll do is, right now I've got like a symbol struct. This can be copied. We'll just say that this is going to be the relocation. So the relocation needs to know what section the relocation applies to. We need to know the offset in the it is the offset. The offset is actually address, so we may as well just keep that as... maybe I'll put offset as int, so I don't have to convert everything all the time. So we'll do offset is int. So that's the offset within the section. Then we're going to need a symbol. So let's say that this is symbol. And then we need an addend as well. So the addend is like the adjustment that you apply to account for, you know, processor specific or like architecture specific differences. So if, for example, we are, let's say, for example, that we've got some, you know, bytes here, which is like a call or something, and then we're saying that we've got 4 more bytes here. So the offset of the relocation will be, you know, 1. But in x64 or x86, the relocations, the jumps are actually relative to the start of the next instruction, which is here. So if we wanted to, for example, jump, you know, let's say it's like 10 bytes ahead of this location here, you know, if we've got 1 and then we've got some location over here that we want to go to, which is at byte 10, then, you know, we want to get to byte 10, so we do 10 minus 1 equals 9, but 9 is too far to jump here. So we need to have an adjustment, which is the addend, which in this case is to minus 4 bytes from this. So if we minus 4 bytes, then we would get the actual sort of like number of bytes to jump forwards would be 5. So the addend is just for the adjustment of the architecture specific requirements here. And then if there was like an immediate on the end of this, we would put, for example, maybe the addend would be 8 instead or something like that. So we'll have an addend, we'll leave this as int. I suppose it could be byte, but I'll leave it as int. So we're going to want a way to add relocation. And to be honest, I could probably just have this append to the like f.relocations, but just to keep the API consistent, we'll do relocation like this. And we'll say f.relocations equals append f.relocations, and then we'll push in the relocation and we'll return the relocation as well. So nothing to actually update on the relocation at this point, but we'll have it in here just in case. So we'll say we've got symbols, we've got relocations. Okay. So then if we have relocations, then it means that we must have symbols. So I think I can do the relocation stuff within this if statement here. So we'll do the symbols first, and then we'll do all of the relocations. So we'll say for, let's say, rel range over f.relocations. So at this point, what we want to do is make sure that we've got a relocation section. So let's go to special sections here. So we're going to use relocation with addend, which is this rel a1 here, and then it says name because the convention is basically to have rel a dot then the section name. So this would be, for example, rel a dot text or something, if these are the relocations for the text section. So if we're going through these relocations, then I think what we would want to do for each one is basically find the section. Well, we've got the section already. What we'd want to do is find the relocation section that has the same name so that we can append into that data. So let's say that we've got rel A can be a section. So for each of these relocations, we want to find the section that has the same name, or the name that matches up for this section. So we'll say for each of these sections, we'll say that if the section name is equal to rel a plus section name, or plus, this would be rel.section.name, then this is the relocation section that we're looking for. If we didn't find it, so if this is nil, then we'll create it. And we'll just say that we'll put this in here, so it's nil on each loop around. So this will be f.addSection. In this case, the name will be this, so we'll say this will be like rel a name. Okay, so we'll do that and put this in here as the name for this section. So the type for this section needs to be rel a. And we'll just say that the address align is 8 for this as well. Although I guess it doesn't need, yeah, we'll say it's 8. Okay. Then we've got, so we've got rel a, we've got C below for extra data, for flags. If the file has a loadable segment that includes relocation, the section's attributes will include the alloc bit, otherwise it will be off. We'll just leave it as off for now, so we'll just leave it with this. So now that we've got this, this relocation section added, we can basically go through it and add relocations in the same way that we do with this symbol table data. So let's just copy this down. And if we have found this for the first time, I suppose what we'd want to do though is just make sure that anything, it's all cleared out, all of the data for consecutive runs. I'll leave it for now just so we can get it working. So we'll just put this to relay.data. So we're going to append relocation into here. So we'll change this to rel a, and we'll put these fields in. So the offset for this is just going to be rel.offset, which will convert into elf address, elf64 adder. Now info here is going to be, we can just use the helper that we've got in elf. So this is going to be this R info one. So we're taking the symbol index and the type. So let's go to relocation. So we've got the symbol here. We need the type of relocation though. So we'll say type here is going to be, I suppose we'll just make this the X word one here. Okay, let's get the helper. So the symbol index, I actually need to add the indices now. So a symbol needs an index, which we'll store as X word, because that's what we need to pass into the helper. Yep. So after we do the stable sort, and we go through all of the symbols, I need to make sure that each symbol index is actually set. So this will be X word, and then I can use this as part of the relocation. So let's go down to here. So we've got the symbol index, and then we've got the type. So this will come from the rel.type. And then we've got the addend, which will be rel.addend. And this will have to convert into SX word. Okay, so let's just see what's missing. Undefined sim. Right, this should be rel.symbol index. Okay. Right, let's try to go to main, and we'll just make up something. So we've got all of the symbols being added here. We could say, so we know, for example, what the... do we know what it is at this point? So... yeah, I think for now I'll just say ef.add relocation. And we'll just copy all of these fields over. So the symbol here, we could, I'll have to figure out how I want to keep track of the symbols, but for this sort of test, I'll just say that it's going to be ef.symbols 0. The section I'll just say is text for now. The type, so we'll do something like, so we've got r underscore, let's say it's this plt one. Oh no, not plt, this will be, I think there was function or something, or what were these called? Is it STT? Let's go to relocation. The type of relocation to apply. Oh yeah, so it is actually the, yeah. All right, let's go to just put PLT in here or something for now. So we'll say offset is going to be, let's just make it 1 at the moment, and we'll just say that it's -4 for the offset. We just want to check that it's being written properly. So let's read elf. So we do actually have the relocation in here at offset 1 with the info says 4 here, so the type is PLT32. Then we've got symbol's name. Oh, this should probably be symbol 1, shouldn't it? Because 0 is the null symbol. Okay, that's better. So we have the offset, which I'm just pretending is 1. The addend, well, this is not the addend, this is the addend here, so this is -4 of the addend. It's underscore start, because I've told it that it's symbol 1, which is this one down here, so that starts. And then the type 4 here is this PL32. The addend is just that separate thing, so this is the name plus the addend here. So then the symbol's value is 5. Yeah, so that's the 5 from here. Okay, I think that's all working okay as far as actually writing the relocations goes. Maybe I should try and actually use the relocations to do something. So let's say that I want to... okay, let's say that I want to use libc or something like that. So let's put start up here. di I'll keep as 123, but instead of doing a syscall for exit, I think maybe we'll just do a call for dword, and we'll pass in enc.f, so we'll do a fixup for exit, will be the symbol. So right now, if I just hard code this, what we'll do is we'll say for the fixup range over encoder fixups. Let's just go to encoder and check this. Yeah, so it's fixup, which is fixup sites, which has all of these things on it. So what we could do is say that we've got like a relocation type, which is this. So we'll do a switch on this for fixup.kind. In the case that it's a fixup branch, we'll just say that type is PLT32. And in the case that it's memrel, we'll say that it's PC32. Then we want to actually add the relocation, so let's just go into this. We'll just say that the add end is hard-coded as a -4 right now. The offset is going to be the fixup offset. This is going to be the type that we chose. The section we'll just hard-code as text right now. And then we need to know which symbol it is, which we could match together by using this label ID here. So we're adding symbols based on label IDs. So we could say, for example, that symbols for now is a map, for this test, we'll say that it's a map of int to symbol pointers. So let's make that. Then we could say that we've got the ID equals this. So we'll basically assign the symbol that we've added, so that'll be the pointer to the symbol, into this symbol's map by the label ID. Then it means that we can get that label ID from fixup.labelid, and that can be the pointer to the symbol that we're going to use. Oh yeah, I don't have enough things in my fixup call, so this will be a fixup branch because it's a call, and then we're going to say that this is so this will be like ip.d, so this will be like a rel32 call. Let's read elf. Okay, so let's just check this. The symbol's value is currently this, which is -1. Maybe I'll just make sure that that's zeroed out or something for now. Not that it should really matter. We're doing a relocation for exit with -4 because it's a rel32 call instruction, so we need to adjust it by taking 4 off of whatever the calculation is. PLT32 because it's going to be a call. The offset is 6, so we'll check that in a minute. Actually, if I do object dump, it should just show me anyway. So if we do object dump here, file not recognized. Okay, so we've got some errors up here. Yeah, ent size needs to be set in the relocations. So when we add section for the relocation, the ent size needs to be set in the same way that we do for symbols. But this will be rel A. Oh, I've got go run here. Okay, let's do go run with that. Okay, so we're doing an object dump on testing O after we run it. So if we look at this now, so this is obviously working because it's actually doing the object dump. So we've got the mov of 1, 2, 3 into the AX register here. And then we're doing a call, which currently is just set to the offset 0, 0 for the entire roll32. But the offset for the relocation itself is 6 because it's 5 plus the 1. So we're at offset 6 for this. We got a -4 addend because it's 4 bytes that we need to take into account here. So let's just run the read elf again. So this time there's no errors. Oh, there's a warning here now. So this is for rel A. So link should be a symbol table section. Yeah, okay. I should have looked at this in the documentation first. So we got section link and info. So for rel A, it's the associated symbol table, which will just be symtab. So that is, did I leave that as link or something in here? Yeah, so we just got link and info in here. So link for this one is going to be symtab dot index. And that's a word. So that's the link, is the associated symbol table. And then the info is the header index of the section. Okay, so info in this case is going to be rel.section.index. Okay, I assume I'm going to have to do a conversion on that as well, so let's just do go run. Yeah, so this one's going to be word as well. So let's just change that. Okay, let's read elf again. No more warnings, I don't think. Okay, so we've got link and info are being set correctly. These are indices. So link was the symbol table, which is 4. Info was the section, which is 1, so that's going to text here, so that's fine. The type is rel A, which is fine as well. We've got rel A text because it's relocations for the text section. Then our relocations, okay, I still need to set this to 0, I think, ideally. Probably not needed, but I'd rather it be 0. This is a relocation for exit with addend -4. We've got 4 here, which is the type, and we've got 2 here, which is the symbol index, which is exit. And then we've got offset 6, which we already know is correct. So that's okay. Last thing to do here then, at least in main, I think I just want to change this offset. We'll just say that it's the max of 0 and fix up offset at the moment. Oh, okay. Maybe not that then. So we've got fix up offset. Maybe I'll just put it here. We'll say offset is this. If offset is less than 0, then we'll just set it to 0. Oh, is this because this is the symbols value, right? This is not the offset. Okay, we'll keep the offset as a max 0 and offset anyway though, because that will be -1 if it's undefined. So for the symbol, maybe I'll just do the same thing. We'll just say it's the max of this and this, just to tidy it up a bit. Okay, so that's 0 now. Not that it's particularly important. Okay, so if I do a link, and actually maybe with this I'll just test if it can be done as a position independent executable, because I should be writing position independent code at least. So we want to link testing, we'll link libc, and the dynamic linker. Dynamic linker will be, is this what was it, lib64 maybe? Lib64 LD Linux, yeah, okay, that's the dynamic linker. So we'll try and link with that, and let's do a.out. Okay, segmentation fault. Okay. I'm not sure I can think of why this is right now. So we've got exit here. We're doing a call. This is correctly PL32 here, which is offset 6. We've got exit -4. Yeah, I would have thought that that would be correct. Okay, well, I think I'm just going to have to look at this another time and come back to it, but relocations seem to be coming out in the correct way, so I'll leave it there for now. Okay, so as soon as I stopped that, I just realized what the problem is, which is that I'm always defining a section for the symbols. So I'm basically saying that exit has been defined in the text section when it hasn't. It needs to be set as an undefined section, which means passing in nil here. So if I take this offset and replace it with a variable, we'll start it in here. We'll just say that if the offset is less than 0, it will be -1 if it's not defined. So if it's just a fixup, it will be set to -1 as the offset. So in this case, we'll just set something like section to nil, and we'll say offset is 0, just to clean it up a bit. And here we'll just say that section is hard-coded to assume text right now. And then instead of text here, we'll just pass in section. So that should be enough, at least with all of these hard-coded assumptions, to make this example work, at least. So if we go run this again, and then do the LD with position-independent executable, testing.o, libc, and then the dynamic linker, and then run it, now it doesn't segfault. So now if we do an echo for the return code, we get 123. Which is the value that I passed into the DI register for exit to use as its first argument. So I think that this should also mean, actually, that I might be able to call printf as well. So perhaps what I'll do is I'll keep this here. And then maybe what we'll do is just say, let's pass in a fixup to the first argument. So the fixup will be something like, well, this will be an address. So we want the address of a string. So we'll say load effective address. We'll do keyword, I suppose. So load effective address of some fixup, we'll call it format. This one will be memrel, so we'll do ip.m for a memory address with displacement 0 right now. Is load effective address keyword right? Let me just go to the encoder assembly. Yeah, I think this should be okay. Yeah, that looks like it should be all right. Yeah, so load effective address keyword into DI. We want the wherever format is in like an RO section, a read-only data section. Then I think the second argument in the ABI here was SI, maybe. So I think if we pass in something like, we'll do like a string which says like value equals and then some number. So we'll do a mov of a D word into SI, where we'll mov, let's say I 42. Then we'll do a call, oh actually printf is variadic, which means I think that we need to set a x to the number of variadic vector registers, I want to say, which will be 0 in this case. So we need to do that. Then we can do a call to print f, which will be fixup branch. And because I got this fixup memrel for data, I can't assume, for example, function here. This would have to be object, I think. But I'll deal with that in a minute. So in this case, then, we need a read-only data section. So we'll say ro data. Let's just copy this stuff. Equals ef.add section. This will be ro data. This will be prog bits. I'm pretty sure that flags is just alloc here. We'll say address align is just going to be 1 for this. Don't think it matters here. And for this one, we'll just hard code a byte slice to say value equals something. So we'll say D, and then we'll do the null terminator and a new line. So the offset of this is actually just going to be a hard-coded 0. I think I've got a syntax error somewhere. Invalid. Oh, this should be X. Okay, so not using ro data, that's fine. So basically, I think now that we've got fixups, we can say we want to have like a bunch of definitions, I think. So we'll just say defs. Let's do type def. We'll do struct. Then what we'll do is say that the how should I do this? Read-only data needs to be section here, yeah. So we'll have a type of def, which can be a struct. We'll have a section that will be a pointer to a section. Defs can just be a map of string to def. So this will be, for example, in this case, we'll do, so we've got start, format, printf, and exit. So start is just going to be section text. All of them are section text except for format, which is ro data. We'll also need a type, which is just a byte, I think. So we'll say type is a byte. And for format, this is going to be object. Then we'll also provide, let's say we'll provide an offset, because we don't have an offset on a label for the ro data right now. So we'll say offset is just int. In this case, its offset is, well, it's just 0 in this case. I mean, what I could do is just use add string as well, though. So we could say that format offset is add string. Let's do this instead of that. So that is already the offset. Then we can just use in here, we just need to look up the definition. So we'll say, for example, let's get the definition. We'll go to defs and we'll look it up based on the name. In here, we'll put the type and the offset. Let's look up the def up here. And we'll just say that if the label offset is less than 0, then that means it's undefined. Then we'll just set it to def.offset, I guess. And then instead of section here, we'll do def.section. Is that enough? Cannot use that. Okay, so this is int. Okay. So I need to take the offset here. We'll just transform, convert that to int. Then we've got undefined section. Def.section. Okay, yeah, we don't need that. And actually, exit and printf are not defined here, so we'll just put those as nil. Okay, let's do read elf. So we've got PC32 for format, with addend is -4 again. That should be okay. So that's the relocation at 3. Then we've got PLT32 for printf and exit, which are both the external function calls. So exit is undefined in here. Printf is also undefined in here. Format is in section 2, which is our data now, which is just this alloc here. Alignment 1. Can't see any errors. So let's just see if object dump is any good. So here we've got a load effective address for RDI, which is just this rip relative plus 0 because it needs to be relocated. So the offset 3, which is the offset of format at this point. So offset 3 is PC32 for format. And then we've got PLT32 for printf and exit. So I think if we just link this and see if it actually works or not, and then if I echo the results, yeah. So we print f value equals 42, and the return code is still 123 because I'm passing that into exit here. Okay, so I guess that's it for relocations at the moment.